Hi, my name is Talia. I'm a high school senior and I love teaching others about chemistry and math. This YouTube channel is an extra resource for anyone who may be needing some help in their chemistry classes. This week, I'm going to be talking about gases, and specifically, I'm going to be introducing the unit of gases with a discussion on pressure. So if you need help with pressure, feel free to keep on watching. And without further ado, let's get started. Okay, so in this video, I'm going to be talking about mainly pressure and how to calculate pressure, force, and area given specific equations. So just as some background information, this unit we are going to be talking about gases, and it's important to know that the Earth is composed of nitrogen, oxygen, argon, and other gases, and each of these gases take up a different percentage of the Earth's atmosphere. So an important concept in chemistry is kinetic molecular theory, which just basically says that particles are always moving, and as you increase temperatures, particles will move faster and will spread apart. And as you decrease temperatures, they will come together and slow down, which will cause molecules to occupy a smaller volume. And then also when atoms or molecules collide with the surface, they exert pressure. So when calculating pressure, you can use any of these three equations. These are just like the density equations. Each version can be derived, and they just each solve for a different variable. So pressure is defined as how much force is exerted on an area, and you can calculate it by doing the force over the area. The force can be calculated by the pressure times the area, and the area can be calculated by the force over the pressure. P represents pressure, which is in units of pascals. Force is represented by F, which is in units of newtons, and area is represented by the variable A, which is in units of meters squared. So if you do not have these units, you need to convert to them. So like if you have kilopascals, you need to convert to pascals. So with these three equations, we're going to try some examples. So first, how much pressure is experienced when 180 newtons is applied over an area of 15 meters squared? So I am going to use the equation pressure equals force over area, and I'm going to just plug in what I know. So I have 180 newtons over 15.0 meters squared, and if you just plug that into your calculator, you get a pressure of 12.0 pascals. Our second problem, we have calculate the area if 200 newtons of force creates a pressure of 30 pascals. So we are going to use the equation area equals force over pressure. So we are going to plug in what we know. We have 200 newtons over 30 pascals. And that is going to get us an area of 6.67 meters squared. So that's a fairly straightforward concept. You just have to know which variables you have and which one you are trying to find. Now, there are also different ways to measure pressure. Pressure is the tool that is used to measure pressure is a barometer. And basically what you do with a barometer is fill it with mercury, and then you invert a tube inside the mercury, and the Earth's atmosphere will push the mercury up the tube, and that will tell you the magnitude of the pressure. So the greater the air pressure, the higher the tube is going to move. And at sea level, the pressure of Earth's atmosphere is 1 atmosphere, and the temperature is 0 degrees Celsius. So we can use that 1 atmosphere to convert in between different units of measuring pressure. So at sea level, a column of mercury in a barometer will move up 760 millimeters, and the pressure will be 101,325 kilopascals. So that then creates this conversion that 1 atmosphere is equal to 760 millimeters mercury, which is equal to 101,325 pascals. And you can use this conversion to convert between different units of pressure. So let's do our first example. If we have 6.08 times 10 to the 5th pascals, we want to figure out how many millimeters of mercury that is and how many atmospheres. So I always like to convert to atmospheres first because it's a nice unit of 1. So I'm going to write 6.08 times 10 to the 5th pascals times 1 atmosphere over 101,325 pascals. And that is going to equal 6.00 atmospheres. And now we can multiply that by 760 to get 4.56 times 10 to the 3rd millimeters of mercury. And you will get the same thing regardless of which unit you convert to first. I can show you down here that let's say you started with 6.08 times 10 to the 5th pascals and did the conversion fraction. That 760 millimeters of mercury equals 1,325 pascals. You would get 4.56 times 10 to the 3rd millimeters of mercury. I just like to do everything to atmospheres first because then you don't have to multiply by 760 and then divide by 101,325. You can just divide by 101,325. And these conversion fractions are just like stoichiometry, just like metric conversions. You just want your units to always cancel out. And that leads you to form the conversion fraction in a certain way. So now we're going to do 304 millimeters of mercury and convert it to pascals and atmospheres. So I'll do this one converting to pascals first so you get a feel of what it's like to not convert to the unit of 1 immediately. So I'm going to write 304 millimeters of mercury times 101,325 pascals over 760 millimeters of mercury. So I'm going to multiply 304 by 101,325 and then divide by 760 to get 4.05 times 10 to the 4th pascals. And then now we're going to convert that to atmospheres. So 4.05 times 10 to the 4th pascals times 1 atmosphere per 101,325 pascals. That is going to get 0.400 atmospheres. So I'm just using the equivalence between these 3 units to write conversion fractions, and then that makes it very easy to convert between the units, which will often come in handy because certain equations only use atmospheres, and sometimes you might be given pascals and might have to convert. So this is an important tool, and just like other conversions we've done, so it should be pretty straightforward. So that was this week's video. Next week, I'm going to start talking about different gas laws, which I'm going to divide up into 2 videos, just because there's a lot. So feel free to join me back next week if you would like some help with gas laws. As always, feel free to leave any questions you have in the comment section, and I will do my best to answer them. I hope you enjoyed, and good luck with learning the rest of your chemistry.